to n, and we have discussed many problems on that, and some different examples also we have discussed. Okay, sure. Okay, now one more property is as I told you, effect of division by t. It is not t raised to n because integration n times becomes very difficult, so we have taken t or maximum t square. Okay, t square means, see, if you have L of f of t is f bar s divided by t, it is given by integration s to infinity f bar s ds. So which is f bar s ds means that is nothing but a Laplace transform of this given function, which will be in the numerator. That you should find Laplace transform of numerator quantity, and you have to integrate that in. Is that clear? Clear?
Yes, sir.
Okay, 1 minute. Okay, then now we need to. There are few examples, and I think yesterday we solved this example. We solved, no?
Yes, sir.
Second example is to find a Laplace transform of cos AT minus cos BT divided by T. Cos AT minus cos BT divided by T. Now, in this case, what happens? This is your f of t, numerator quantity. So, it is divided by t means what you have to do? Integration s to infinity Laplace transform of this. Okay. Next, what you have to do? Laplace transform. This means since here negative sign is there, two terms are there, so difference of two terms are there. So operate this Laplace operator separately to this. Since it is a linear operator, you can operate this separately to both. So Laplace transform of cos AT, it becomes s divided by s square plus a square. Laplace transform of cos BT, it becomes s divided by s square plus b square. Now one stage is over now. Am I right? One stage is over. So what we will do next? Next, we will first integrate, taking integration separately to these two. Okay. What is the integration of s divided by s square plus a square? Which formula we are going to use here? It is the standard formula. Is one of the standard result is integration of f dash x divided by f of x dx. It is given by what? What it is given? Yes, can anybody? It is a log of f of x, denominator quantity. Okay. Now here, if you, I will write this one as 1 by 2 times log s square plus a square. Why? Because if you differentiate s square plus a square, what happens? It becomes 2s, 2s. But in the numerator, what you are having here, only one s. 2f, if it is there, then you would have written directly log s square plus s square, integration of this. So this 2 comes extra in the numerator here. So to manage that, what you have written? To balance that, 1 by 2 times log s square plus a square. Likewise, likewise integration of s divided by s square plus b square, it becomes 1 by 2 times log s square plus b square. Log s square plus b square, limits are s to infinity. Now what we will do, this 1 by 2, this 1 by 2 is common in both the terms, so I will take that outside. Okay, to avoid the confusion in the simplification. Now I will put the upper limit infinity here. So there are many techniques to simplify this, but I am going to use it directly. Another technique is taking s square common using the properties of logarithm. That becomes a little bit lengthy. In the future examples, if possible, in one or two examples, I will use that property and I will give you the both the methods. Okay. Now here directly, if you put infinity, what happens? Log infinity plus a square minus log infinity plus b square. But what happens here? This becomes log infinity. This also becomes log infinity. So first I will simplify this. Then minus 1 by 2 is already taken common. Wherever s is there, in place of s, you need to substitute s only. So what happens? These two terms remains as it is. Log s square plus a, log of s square plus a square, log of s square plus b square, which we have written here. Okay. Then next, what happens? This term becomes log infinity becomes 0. Here also log infinity becomes 0. So entirely what happens? This upper limit goes to 0. This upper limit goes to 0. Now minus of, you left with what? Log s square plus a square minus log s square plus b square. Now what we will do? We will take this minus sign inside the bracket. If we take minus sign inside the bracket, then what happens? Minus into minus. This becomes plus. So I have written this term first here. 1 by 2 as it is. Log s square plus b square minus log s square plus a square. Now, what happens? This is of the form log a minus, if you take this as b, log b. What is the formula for log a minus b? Yes, log a, not
Log A by
log, not log a minus b. I am sorry. This is log a minus log b. It becomes what? Yes, log of,
log of A by B.
okay, good. Log of a by b. This is not 9, this is a. Okay, log a by b. So this is your a, this is your b, means you can write it as a log s square plus b square divided by s square plus a square raised to 1 by 2. I have written it because see, you can use using the properties of logarithm directly. I have written n log m, n log m. This can be written as what? Log, sorry, I'm just 1 minute. Log, this is log. Okay, so using that, it becomes a, okay, so this is, this raised to 1 by 2 means you can write log underscore root s square plus b square. Okay, so further if you want, you can take s square common in the numerator, s square common in the denominator, cancel them. You can write this answer as log of underscore root 1 plus b square by s square divided by 1 plus a square by s square. Instead of that, if you write only this much, that is also right answer. Okay, is that clear? Is
Yes,
that
sir.
clear? Okay, hope that is clear. Now,
Okay, sir.
am I audible clearly?
Yes, sir.
Yes, sir.
Okay. Okay. Now we will go to the next one more example. Here, log of, you have to find a Laplace
Yes, sir.
transform. Okay, Laplace transform of sine hyperbolic t divided by t. So, what is your f of t here? This is a sine hyperbolic t. It is a your numerator. So this is your f of t. So you have to write a Laplace transform of that sine hyperbolic t divided by t means one time t means integration s to infinity with respect to s. Okay. Now, what is Laplace transform of sine hyperbolic t? A is equal to 1 here. So if it is sine hyperbolic at, you would have written a divided by s square minus a square. But it is what here? Sine hyperbolic t. So I will write this one as 1 divided by s square minus a square with respect to s. Okay. Now, if you write like this, if you write like this, again what happens? I have used different techniques in the next stage, but just I wanted to tell you why I have taken this. If you write like this, here in writing integration directly for this becomes or that result, standard result, if you remember, it's okay. Otherwise, it becomes very difficult. Very difficult means you have to split this into partial fractions, then apply the whatever the thing is for the integration. Okay. To avoid that complication, what we can do is here I have written R. You can write this Laplace transform of sine t as using basic definition. You write a Laplace transform of sine hyperbolic t. That is Laplace transform of sine hyperbolic t is e raised to t minus e raised to minus t divided by 2. Uh, Somebody, if you remember standard result for this integral, you can write it directly. Otherwise, please go for this method so that it becomes easy. Okay. Now, up 1 by 2 is a constant here. We'll take that outside. integration s to infinity as it is. Now apply Laplace transform this e raised to t and apply Laplace transforms this e raised to minus t. What happens? Laplace transform of e raised to t is 1 divided by s minus 1 minus Laplace transform of e raised to minus t is 1 divided by s plus 1. So s plus 1. I'm sorry, here it should be 1. By mistake, I have written it as a square. It is a standard result. Okay, please make the correction here. This is 1 square. Okay. Now what we should do there in this case? Okay, now this is one term separate, this is one term separate. So I will integrate these two separately. So 1 by 2 as it is. Integration of this becomes what? If you differentiate this quantity, that becomes a 1. So directly you can write log s minus 1 minus as it is. Now if you differentiate this in this case, in this second term case, so what happens? Differentiation of this is also 1. So in the numerator you are having 1. So it becomes log s plus 1 limits of s to infinity. Okay. Now putting the upper limit. So it becomes log infinity. This also becomes log infinity. So completely upper limit becomes what? 0. I have written it directly. Will it be okay? Will it be okay? Okay. The next minus,
Yes, sir.
wherever s is there, you have to write s is equal to s only. So it becomes minus, lower limit is s only. So this term remains as it is. Okay. Now taking this minus sign inside the bracket, what happens? This becomes plus, this becomes minus. So I written 1 by 2 times log. Actually, I'll write one thing here. 1 by 2 times I'll avoid because I already written. So it becomes log, sorry, 1 minute. It becomes a log s plus 1 minus log s minus 1. Am I right? So using the properties of logarithm, directly you can write this one as treating this as a, treating this as b. You can write this one as 1 by 2 times log s plus 1 divided by s. Property of logarithm, take this 1 by 2 to the power here. It becomes a log s plus 1 minus, sorry, divided by s minus 1 raised to 1 by 2, which can be written as a log or s plus 1 divided by s minus 1. Is there any queries with this example? Is there any difficulty with this example?
No, sir.
Is, can anybody tell me, is there any difficulty with this example? If it is clear, we will move forward. Is it clear? Is it
Yes,
clear?
sir.
Okay. Next example is finding the Laplace transform of t sine t square divided by t. See, if it is divided by t means definitely you are going to get by using third property integration s to infinity with respect to s. No issues with that. Here we have to concentrate on this numerator part. Numerator part, if it is only sine t, you would have written it directly Laplace transform of that. But what is happening here? It is sine square t. So according to the rules, first we will write down that. Now for sine square t, it is not in the standard form, okay, because of presence of this square. So using using yes, using sine square theta, sine square theta is equal to 1 minus standard formula, 1 minus cos 1 minus cos 2 theta divided by 2. What we will do, we will, in place of theta here having t here, using that you can write this one as integration s to infinity cos 2t divided by 2. Okay, is this clear? It's converted here. Still you have not found the Laplace transform. We have reduced it to the standard form. Now 1 by 2, it is taken common here. Then integration s to infinity, Laplace transform of you left with the 1 minus cos 2t with respect to s. Okay. Next, apply this Laplace operator on these two separately. If you operate this Laplace operator on this, what happens? What is Laplace transform of 1? 1 by s minus Laplace transform of cos 2t is s divided by s square plus 2 square, which is 4. So I have written it directly. Okay, with respect to s. Now we need to integrate this quantity between the limits s to infinity. Now, what is integration of what is in 1 by 2 as it is? What is integration of 1 by s? It is a log s. What is integration of s divided by s square plus 4? Can anybody? Yes. What is integration of s divided by s square plus 4?
1 divided by 2 log of s square plus 4.
Because if you differentiate this, you will get a 2s here. So to balance the equation, to manage that, what you have done? 1 by 2 here. So 1 by 2 times log s square plus 4 integration. Sorry, limits s to infinity. Now put these limits. If you put these limits, what happens? Already you have solved 3 examples. So I have written here. Once I will explain. If you put this infinity here, it becomes a log infinity 1 by 2 times, okay, log infinity plus 4, which is again log infinity. So upper limit, it becomes completely 0. Okay, next minus. What is the lower limit? The lower limit is whatever the term remaining itself here, because you have to put s is equal to this s only. Am I right? Sure or not? S is equal to, we need to put S only. Okay. Next, it becomes log S. Then this is 1 by 2 times log S square plus 4 only. Log S square plus 4 only. Next, we have to take this minus sign inside the bracket, so that this usually happens. So that see, before writing that, before taking inside, so what you will do is, for this term 1 by 2 is there, so I will use basic property of logarithm, and I will write this one as log under square root s square plus 4 minus this log s. So one more 1 by 2 is remaining there. So what you can write again, treating this as a, treating this as a b, you can write this one as log underscore s square plus 4 divided by s raised to, again using the properties at once. So simultaneously, I'm sorry, simultaneously you will get 1 by raised to 1 by 2. So again, raised to 1 by 2 means you can take square root of this. You can write log underscore root s square plus 4 whole divided by, sorry, this divided by yes. Okay, this is entire thing is inside the whole underscore root. Okay, hope this example is clear.
Yes, sir.
Am I going a bit fast? The speed is okay?
No, sir. Yes, sir.
Okay, we'll go to the next example now. One more example. Find the Laplace transform of 2 times sin t sin 5 divided by t is present means what is the meaning of that? Integration s to infinity, it is fixed, and here it is by the property that is a ds. With respect to ts, you need to integrate in between the limits s to infinity. Now the thing is, this is your f of t. You have to find a Laplace transform of this. So which we have written here, Laplace transform of 2 times sin 2t sin t, sorry, sin t into sin 5t. Now again, if it is a see, if this term would have not present there, only sin 2 with the if it is there 2, we are going to take common, we are going to find only Laplace transform of this. Or else, if only sin phi t is present, what you would have done? You would have taken directly. Now, product of two terms are there. Since the product of two terms are there, we cannot use directly linearity property. That means we cannot directly apply Laplace transform to this, Laplace into Laplace transform to it. For that purpose, what we need to do? We need to reduce this to the sum or difference of two quantities, two functions, so that we can use Laplace transform operator directly. So I have taken this term common because you are familiar with the one of the standard result product to sum, that is sin A into sin B. If both are sine, your answer will come in terms of cos. This can be written as 1 by 2 times 1 by 2 times what we are going to write, cos, can anybody, cos
A minus B.
cos A minus B, yes,
minus
minus,
cos of A plus
okay,
cos
good,
of A plus B.
okay, good, cos A plus B. These basic standard formulas, please, you should remember. So that if you simplify this, you will get 2 times sin A, sin B. These two we are written here to manage that. Otherwise, if you keep this 2 as it is here, directly you can write only avoiding this 1 by 2. Directly you can write 2 times this is equal to, you can cancel this. Okay. Is that clear? Pakka no? All of you. Okay. Now using this result there, using this result, given quantity or given function can be written as Laplace transform of cos 5t minus t. I have taken this as a A, I have taken this as B, nothing to worry. If you take this as a A, this as B also, no issues whenever it is cos. Okay. Now cos 5t minus t minus cos 5t plus t whole divided by 2. Now what happens? These two get cancels because that is constant quantity. So you left with the integration s to infinity Laplace transform of cos 4t minus cos 6t with respect to s. Now Laplace transform of cos 4t is s divided by s square plus s square plus 16 minus s divided by s square plus 36, because here a is 4, here a is 6. Okay, now you got this. Now we have to integrate this. Already you are familiar with this. So directly what you can write for this integration, for this quantity you can write integration of s divided by s square plus 16 is 1 by 2 times log s square plus 16 minus for this 1 by 2 times log s square plus 36 s to infinity. Now again 1 by 2 is constant, you take that outside. Okay, then it becomes a log s square plus 16 minus log s square plus 36. So using the properties, I have written it directly. Now s to infinity, sorry, this is not s is equal to 0. Make the correction there. It is a s to infinity. By typing mistake, I have written here. Please don't worry about this. Okay, this is s is equal to 0. Sorry, s to infinity. Now here I use different technique to simplify this. Okay, for our convenience. So what we did here, if you want, you can put directly limits here, upper limit, lower limit, directly you can write answer. But you must know this method also. In some book they are given this method, so I have taken this method. So here in the numerator, 1 by 2 you keep as it is, log you keep as it is. In the numerator, take s square common. If you take s square common, what happens? It becomes 1 s square into 1 plus 16 divided by s square. In the denominator also, you take s square common. What happens? It becomes s square 1 plus 36 divided by s square. Now what happens? Here this s square cancels. So only this thing is left. Only this thing is left means next we have to put infinity here. Okay, if you put infinity, what happens? Log upper 1 by 2 as it is, log upper limit. If you put infinity here, what happens? It becomes log 1 plus 16 divided by infinity. Anything divided by infinity is a 0. So this becomes a 0 when you put the upper limit. So this is 1 plus again 36 divided by infinity. This also becomes a 0. So it becomes here log 1 divided by 1, which becomes log 1. Is that clear? Is that clear? Is that clear? Okay.
Yes, sir.
Minus, this is another way of simplifying. Okay, minus log, wherever s is there, you have to put s is equal to s only. So these terms remains as it is. That is 1 plus 16 divided by s square whole divided by 1 plus 36 divided by s square. Now what is the value of log 1? Log 1 value will become a 0. Log 1 to the
0.
base, okay, log 1 to the base e means it is a 0. Now next, this is minus there. If you take this minus sign inside, then what happens? Yes, I will write here minus of log, just I'll drop this, not equal to minus of log minus of log if it is a by b, a by b. How you are going to write? Minus you will keep as it is. You are going to write this one as a log a minus log b, so that if you take this inside the bracket, so what happens? It becomes a, that is equal to log b by a. Am I right? So that this becomes minus, this becomes a plus. Using again property, you will get log b by a. So directly I have written here this 1 by 2 as it is. Reverse these two, interchange these two cases. Log, what happens? 1 plus 36 divided by s square divided by 1 plus 16 plus, sorry, 1 plus 16 divided by s square. Now again what you can do here, taking the LCM. If you take the LCM, what happens? This becomes a numerator becomes a, it is log of, okay, completely. Okay. This becomes a s square plus 36 whole divided by s square in the numerator. In the denominator again s square plus 30, s square plus 16 divided by s square. So this s square in the denominator get cancels. You will get again 1 by 2 times log s. Am I right here? Taking it to the numerator. So this is, I'm sorry, this should be log 36 divided by log 16. Okay, so using the properties, so typing mistake it is, please make the correction. Under log under square root s square plus 36 divided by s square plus 16. This is the final answer. I'm sorry for this wrong typing, but please make the corrections. Is that clear?
Yes, sir.
All of
Yes, sir.
okay. I will make these corrections when I'm putting the notes to you. Okay.
Yes, sir.
Please, I will mark it once again. Please make sure. Please make sure. So yes, this should be 3 here. 36. This should be 1. Here also, this should be 3. This should be 1. Okay. Clear? Okay. We'll take another example, which is a different kind of example. Okay. Now, usually, see what you observed in all the previous 5 examples, almost your exam answers are in terms of what? Log only. Your answers are in terms of a log only. Now we will go for a different example. No? Here, Laplace transform of sine 80 divided by t. Divided by t means again integration s to infinity. This is sine 80, sine 80, f of t is sine 80. So Laplace transform of sine 80 you have tried. You have to integrate this between the limits s to infinity with respect to yes. Okay. Now, what is the Laplace transform of sine 80? It is standard quantity a divided by s square plus a square. It is a standard function or not? A divided by s square plus a square. Now, a I will take outside here constant quantity. Integration s to infinity 1 divided by, I will write this one as a square plus s square or s square plus a square. No issues with respect to s. Now, you remember this. What is the standard result of this? Yes, integration of 1 divided by 1 divided by yes x square plus a square dx. What you are going to write? This is, you are going to write this one as 1 by a into, already you derived this in previous second year, 1 by a into tan inverse. This is x divided by a, x divided by a, isn't it? Now, in place of x here, you have s and integration is with respect to yes. So what you have to, this a you keep as it is. Integration of this quantity, it becomes a 1 by a into tan inverse s divided by a. Compare this and x is equal to, you are having s here. Okay. Now, integration s to infinity. Sorry, limits are s to infinity. Now, this a cancels. You will have to only this. So I will put the limits here. Infinity, s is equal to infinity. Tan inverse infinity divided by anything, that is tan inverse infinity only, then minus lower limit, wherever s is there, put s only, tan inverse s divided by a. Okay, next what happens? So tan inverse infinity value is pi by 2 minus tan inverse s by a. I have written this one as a cot inverse s by a. Whether I am right or wrong? Am I right?
Yes, sir.
How? You tell me how.
Pi by 2 minus tan inverse of S by A is equal to cot inverse of S by.
Okay, that is directly you cannot say that. Say one of the standard results you learned in your inverse trigonometric function from PU second, that is tan inverse x plus sorry cot inverse x plus tan inverse x, or tan inverse x plus cot inverse x is equal to, you are having a, what is that, pi divided by 2. I
Pi
think
by 2.
you remember this result. Okay, now taking this tan inverse to this side, that becomes pi by 2 minus tan inverse x is equal to cot inverse x. So I used this property here. Is that clear?
Yes, sir. Yes, sir.
Okay. Okay, so final answer is what in this case? This is a special example, please remember, because your answer, oh, that's why I told you 99% of the answers in case of divided by property is in terms of log. 1% you will get answers like this. Okay, that is cot inverse s by a. Is that clear?
Yes, sir.
Okay. Now we will take some more different kind of examples on this. See what they will say on the third property, relating to third property. So evaluate the following integrals by using Laplace transforms. Athwa directly they will give evaluate the following integrals. So if they give directly, first you have to observe whether it is possible to do this by direct method, direct any other integration methods or not. If it is not possible, definitely, if it is complicated integral, definitely by using Laplace transforms, you can find the uh, the solution for those complicated integrals. Okay, is that clear? Okay, these are the some important examples. We'll take them one by one. Okay, now see first to find the Laplace transform of cos 60 minus cos 40 divided by t, integration s to infinity dt. Okay, next what you have to do, directly it is not possible to see divided by t means directly it is not possible to use a third property here s to infinity, because already integration 0 to infinity is present here. So for that purpose what we have to do, we have to rewrite this example, rewrite this example as integration 0 to infinity e to the power minus st into s, whatever the given thing is, cos 60 minus cos 40 divided by t. Now by using the definition of Laplace transforms, this becomes your f of t, whatever it may be, please concentrate here. This becomes your f of t, except that e to the power st. Now this is, if we treat this as f of t, what happens? It is integration 0 to infinity e to the power minus st into f of t. So what is that? How we are going to write this? I'm sorry, just 1 minute. What is the value of this? Can anybody tell me? Integration 0 to infinity e to the power minus st into f of t. How we are going to write this? What is the meaning of this with respect to t? Okay. Yes. This
Laplace trans
okay. This is a Laplace transform of
transformers f of
okay f of t. Good. Now what is your f of t here? Cos 60 minus cos 40 divided by t. Therefore, that can be written as Laplace transform of L of cos 60 minus cos 40 divided by t. Now, this is in the third type of case. Okay, third, you can use third property for this here. I will tell how to do in the next stages. Okay. Now this is reduced to the third type of example. Now it is it. Now you have to treat this just now you have to treat now you have to treat your numerator, your numerator, this quantity, you have to treat this as f of t and divided by t. Divided by t means what you are going to do? Integration s to infinity Laplace transform of f of t. This is your f of t. That is L of cos 6t minus cos 4t with respect to s. Now write down the Laplace transform of cos 6t minus cos 4t. Operating this separately because L is a Laplace is a linear operator. So Laplace transform of 6t is s divided by s square plus 36 minus Laplace transform of cos 4t is s divided by s square plus 16 with respect to s. Okay, integration s to infinity. Next, what happens? Yes, what happens? Integration of this is what? 1 by 2 times s square plus 36 minus integration of this is 1 divided by log of s square plus 16. Limits are from s to infinity. Okay. If it is speed, please tell me. I'll reduce a little bit. Then next, we have to put the upper limit and lower limit. So directly, we are not going to bother about anything here, any type of simplification. So directly, we'll put the limit here. So 1 by 2, I will take common. Now I will put infinity here. Wherever s is there, upper limit I will put first. If I put upper limit, what I will get? Log infinity minus log infinity. So upper limit is log infinity is 0. 0 minus 0 again it becomes a 0. So upper limit directly goes to 0. Now I will put the lower limit here. Lower limit, if you put these quantities remains as it is. That is minus log s square plus 36 minus log s square plus 16, whatever you are having here, because already we have taken 1 by 2 outside here. So now this 1 by 2 as it is. Now taking this minus sign inside, so this becomes a log log s square plus 16 minus log s square plus 36. Okay, I'll write here. That is, you will get a 1 by 2 as it is. So you will get the log s square plus 16. Okay, because minus into minus it becomes plus minus log, you will get a log s square plus 36. 36. So again, using the basic properties of logarithms, this is your a, this is your b, this is of the type log a minus log b. You can write it as a log a by b. So I have written here 1 by 2 times log s square plus 16 divided by s square plus 36. So now what happens? Using again the properties of logarithms here, taking it to the m log n property. So you can write log m raised to n. So directly you can write log under square root s square plus 16 divided by s square plus 36. Okay. Now, is it the final answer? Is this the final answer?
No, sir.
No, because we have calculated value of this. What we want value of this quantity, isn't it? Here e to the power st is extra quantity. We don't want to do this. Whatever you got the answer here, this is a value of, see, I written it. Therefore, integration 0 to infinity e to the power minus st into cos 6t minus cos 4t divided by t dt is its value. This integral's value is log s square plus 16 divided by s square plus 36. But we don't want to evaluate this integral in between the limits 0 to infinity. We don't want this here. So to remove this, we have to put what? S is equal to 0. Why? Because e to the power 0 becomes e raised to 0 becomes 1, isn't it? So 1 into anything is that quantity. So putting s is equal to 0 in this, you will get both the sides. You have to put s is equal to 0 both the sides. What you will get? Integration 0 to infinity cos 60 minus cos 40 divided by t dt. So isn't it? Now this value is required. Value of this integral is required. Am I right? So it becomes log 0 square plus 16 divided by log 0 square plus 36. So becomes log 16 under square root 16 divided by 36. So log of under square root 16 means it is 4. Under square root 36 means it is a 6. So log of 4 by 6 you will get. If you simplify this one as a 2 2s are 2 3s are, you will get this value as a log 2 by 3. Now this is actual answer. Is that clear? Is that clear?
Yes, sir.
So please, in the examination, please concentrate. Don't treat this as a final answer. So you have to observe carefully which value you require. For our simplicity or to make the problem simple, we have reduced this problem to the Laplace transform type. Okay, is that clear? Is that clear?
Yes, sir.
Okay. Shall we go to the next example now? Here. What is the next example? Find the Laplace transform of find the Laplace transform of yes. Next example is find the Laplace transform of. Can anybody? Can you see the second example there or not?
Yes, sir.
Find the Laplace transform of. It is. Sorry, I'm sorry. Not find the Laplace transform. Evaluate the integration 0 to infinity e to the power minus at minus e to the power minus bt divided by t with respect to t. Okay, integration with respect to t. Now here directly again if t present I continue directly property use modangilla. You have to concentrate on the limit, and if it is L of this one directly you can use the property. Now we have to convert this in terms of standard form so that we can simplify it easily. Now I will simplify here. Now what you have to do? Consider the original thing, original limit as it is. Then multiply this by e to the power st so that it becomes of the type integration 0 to infinity e to the power minus st into this becomes your f of t. Am I right? Sure. Now
Yes, sir.
using the basic property or basic definition, what you can write? This entire quantity can be written as L of e to the power minus at minus e to the power minus bt. Now here this is L of this quantity. So now we can use third property. What is the third property says? Divided by t means integration s to infinity Laplace transform of numerator quantity, that is integration s to infinity L of e to the power minus at minus e to the power minus bt. Now operate Laplace to this separately using linearity property. You will get integration s to infinity Laplace transform of e to the power minus at is 1 divided by s plus a minus Laplace transform of e to the power minus bt is 1 divided by it becomes s plus b with respect to s. Okay. Now we will integrate this. What is the integration of 1 divided by s plus a? It is log s plus a minus what is the integration of 1 divided by s plus b? It is log s plus b in between the limits s to infinity. Now put the upper limit here. Put the upper limit here. What happens here in place of s? Okay, in place of s. So it becomes what? Log infinity plus a, which is log infinity whose value is 0, log infinity plus a b, which is log infinity whose value is 0. So upper limit directly goes to 0. Upper limit directly goes to 0. Am I right? Am I right or wrong? Hope
Yes, sir.
upper limit directly goes to 0. Upper limit directly goes to 0. So then put lower limit here. S is equal to s only. So minus that term remains as it is. Okay. Now take this minus sign inside the bracket. So this becomes plus. This becomes plus. Okay. Sorry. This becomes a plus. So what I've written there? That is log s plus a divided by s plus b. You got the answer. Is it the final answer?
No, sir.
Hmm, definitely. Okay, good. Therefore, we have got the value of this integral. That is e to the power minus s e to the power minus st into e raised to minus at minus e raised to minus bt divided by d dt. This is answer for this. Now we don't want this quantity. We want only value of this integral involving only these terms. So what we have to do? We have to remove this. For that, again we have to put what? s is equal to 0. If you put s is equal to 0, both the sides you have to put. So what happens? It becomes integration 0 to infinity. E to the power 0 is 1, so no need to write that. Okay. Then e to the power minus at minus e to the power minus pt divided by t dt is equal to, you will get log 0 plus b divided by 0 plus a, which is equal to log b by a. This is your actual answer. Is that clear?
Yes, sir.
Okay. Just for 1 minute, I will give 1 minute time. What you have to do is you have to evaluate this. Try and just just for 2 minutes, I will give a pause. So you please evaluate this. Let me check how many of you are perfect with this. How many of you become perfect with this? Please evaluate this. I will keep this as it is. Okay. 1 minute. 1 minute. Okay. Please evaluate that. I will come. Okay. Tried. Hello. Am I audible?
Yes, sir.
Okay. You tried that? 1 minute. Just I will give one hint here. See, this is, see, here it is, I will tell you. Here it is already e raised to t is present there. Okay. E raised to something minus t or something is present there, isn't it? So what you have to do, don't consider that term when you are using, because here e to the power t is not present in these two terms. Here it is present. So my suggestion is, directly what you do, you consider only these two terms, and in place of this you take e to the power st. I will tell you how to do that. Okay. Now see here. See, I will ignore e to the power minus t term there, and you consider only integration 0 to infinity e to the power minus st sine t divided by t. Now this term is your f of t. Okay. E to the power st into sine t divided by t. Okay. This is e raised to st, so this becomes your f of t. So using the basic definition, you can write Laplace transform of sine t divided by t. Am I right? Now again, this is divided by t, means what you have to do, integration s to infinity Laplace transform of numerator quantity, that is Laplace transform of sine t with respect to s. Okay. S to infinity, integration s to infinity Laplace transform of sine t is 1 divided by it is s square plus 1 with respect to s. Okay. Now what is Laplace transform of s square plus 1 or 1 plus s square? Sorry, not Laplace transform, I'm sorry, integration. What is the integration of x square plus 1 dx or 1 plus x square dx? Can anybody tell me? This is what? What is this?
Log of x. Tan
Tan.
inverse.
Ah, that's why you have
Tan
to.
inverse.
Okay, tan inverse x. So you can write this one as tan inverse s to infinity. Now put the limits. Upper limit is infinity, so this becomes tan inverse infinity. Lower limit is s, so it becomes minus tan inverse. So you will get 5 by 2 minus tan inverse s. Now if you want, you can write this one as cot inverse s also, but I will keep that as it is. So what you got the answer here? Integration 0 to infinity e to the power minus st sine t divided by t dt is pi by 2 minus tan inverse x. Is this the answer we required?
No, sir.
No. What happens? Everything is present, but in place of yes, we don't want this yes here. Okay, we don't want yes, it is a different value there. So to make this e to the power minus t, what you have to just put a, wherever yes is there, both the sides just put a yes is equal to 1. If you put s is equal to 1, what you will get? Integration 0 to infinity e to the power minus t sine t divided by t dt is equal to pi by 2 minus tan inverse 1. Now, what is the pi by 2 as it is? What is the value of tan inverse 1? It is pi by
Pi
4.
by 4.
Okay. Now, pi by 2 minus pi by 4 is how much? It is pi by
Pi by 4.
pi by 4. So, this is the final answer. Is that clear?
Yes, sir.
Okay. Now, what I will do, if it is clear, these remaining examples, please concentrate, please write down these two. These two examples are homework for you. Okay. Will you try this in the same line?
Yes, sir.
Okay. What you have to do here is, here you have to convert this in terms of what? E to the power, sorry, in terms of exponential function. Then consider only this term and take here e raised to st when you are solving. Then apply the third property, then solve it. At the end, put s is equal to 2 in this case. When you consider this fourth example, first you need to consider this example, no issues with the st, avoiding this. Okay, then next again, it becomes, use the third property, it becomes Laplace transform of sine square t. This sine square t should be converted in terms of standard form using which formula? Which one you are going to use?
1 minus cos 2 divided by 2.
Yes, very good. This you can write this one as this sine. I'm sorry, little bit mouse is not moving there. So 1 minute. I'll write it correctly. Otherwise, some people may get confused. It becomes sine square. I'll write in terms of t only. Sine square t, you have to write that one as 1 minus s 1 minus cos 2t divided by 2. After writing this, then you have to find Laplace transform of this. Already we did this in the standard form, but they have given a different way, so you have to convert this, simplify this. At the end, whatever you got the answer in that, you have to put s is equal to 1, then you will get the required answer. Will you try these two?
Yes, sir.
Some other persons, only she is answering, some other persons are understanding or not?
Yes, sir.
Pakka?
Yes, sir.
Okay. Now I will tell you one thing. With this, with all these, we have completed examples and examples on basic standard forms and three properties. Okay. And on the three properties, one more property is there, but that is not for your syllabus, so we are not going to cover. If you require that property, I am going to tell you in the next class. Somewhere it is applicable in your core subject. So I will tell that property also, but examples on that property will not be taken. Now with this, you are one part means not completely. Laplace inverse is also there, but from one part, 80% is completed. So another two types of the Laplace transforms are left. One is called periodic function, another one is called unit step function. So now what I made is, up to this three properties and standard forms. These are some 11 questions from your previous year VTU question papers are there. I have listed here. Okay, I have listed. Clear my point? So what I will do,
Yes, sir.
I will put these notes in the Google Classrooms. What you have to do is, these 11 properties, sorry, 11 examples, whatever they appeared in the VTU question paper, if it is repeated, ignore them. Otherwise, you have to solve all these 11 examples, and you have to make a PDF copy, and you have to put it in the classwork section in your Google Classroom. Will you do that?
Yes, sir.
How much time you required for this, you tell me. Okay, I will put the notes up. I will put this up to this everything now. Next class onwards, we are going to discuss about the Laplace transform of periodic function. Please just go through the definition of periodic function so that it becomes easy for you. Okay. Okay. We'll stop the class here now. We'll stop. Don't exit. I want to take the attendance. We'll stop the class here now. Okay. All are there? Can you see me?
Yes.
All are there?
Yes, sir.
Uh, uh, you do one thing.